Greetings, my students, and welcome to Algebra 1. Today is the first lesson of the year. Very exciting to write that in my brand new book. So I'm going to take just a minute and go over a few basics so that we are on the same page together. Here's our checklist. As you'll notice, this first pair of weeks, we're only going to cover one lesson. How can I say this? 2 lessons a week instead of 4, right? Afterwards, we'll pick up the pace and start doing 4 different lessons. This week and next week, we'll just be doing 2 lessons. I'm still thinking of this as 4 assignments for you, though. It's just going to take you a little bit longer to get going here at the beginning, right? We got to kind of get the wheels moving again, and everything's going to be a little creaky and hard. So I'm giving us some extra time to ramp up. Today, instead of giving you 2 lessons, I'm giving you just 1 lesson. Lesson 1. I want you to do 2 different sessions of homework for that, though. You can do evens and odds. You can do odds or evens, so you can break the lesson apart that way. Or you could do lesson 1, problems 1 through 15, and then problems 16 through 30, if you prefer to tackle the homework in that direction. So you can take the 30 problems for lesson 1, and even though normally we'll continue to just do the odds, for this first pair of weeks, our assignments will be a little different. We're going to do all the problems for lesson 1 broken into 2 different sessions, all the problems for lesson 2, and then the same for 3 and 4. Again, just to repeat, because I can't look at your eyes and see that light bulb going on, you get to break apart. We're going to do all 30 problems for lesson 1 over 2 days of assignments, and you get to choose how to break those apart. Hope that makes sense. Message me if you have any questions. Remember that my phone number is right there on this form if you ever need to reach out to me. There's my email, but just text me. The due dates mean this is when the homework is due. So today's the 13th, or I'm thinking of it as the 13th. You might not be watching this on the 13th. Your homework is due 1 week from now. So this is the first day that you have homework due is the 20th, and you'll have those 4 assignments covering those 2 lessons to be done. Remember to have your parents sign. Remember that when we check in every week on video chat, I'm going to ask to see this. Remember that your parents' involvement in this is a really, really crucial part of the puzzle. We need them, your mom or your dad or whoever, grandma is fine too. We need that person to be really focused in on what we're doing and aware of what's going on so that we all work as an effective team. Okay, this form works just like last year. We've got midterm and review dates on there. We'll be done by the last week of May. I'll talk about the tests as we get closer, but everything's just the same as last year. So literally all I do is change the dates every year and fix up this stuff. This stuff is mostly general information that you know. The class meets online during the pandemic, unless you're vaccinated, and then we can work in person if you want. Interestingly, I already have students who are vaccinated saying, no, online works great. I want to keep doing this. So that's fine too. New lessons will be posted Mondays and Wednesdays. I will send you the links just like I have, but I already have all the lessons on my YouTube channel from last year. So I'm planning to re-record them this year to keep my head in the game, but you can always Google and find the lessons ahead of time. But I will post new ones for you guys, and I'm gonna change the captions to be all uppercase so that you can tell this year's from last year's. You can also tell by the posting date, but I'm trying to make it easy. So this year, as I post new lessons, you'll see that the title, it'll say Saxon Algebra 1, Lesson 1, which is what we'll be doing now, but all of the words will be in uppercase. Last year, it was normal uppercase and lowercase mix. Weekly assignments are due on Mondays, as noted below. These are all Mondays except for the test dates. Parents are responsible for supervising and reviewing their students' progress. Make sure your parent looks over your work each week and signs off on this form. Remind your mom or whoever's doing this that this page that I also mailed you has a section that's called Parents, and that tells them what to look for as they're reviewing your work. So you can remind your mom or whoever that this tells them exactly what to do when they're reviewing. Students who successfully complete this coursework are eligible for an algebra, geometry, pre-calculus, or integrated math credit. See me if you'd like support in documenting this work. Okay, that's more or less a note for your mom, but I can help you if you're trying to figure out how to turn this into a credit. Students whose performance falls below 80% may be asked to complete additional assignments. That relates mostly to our midterms and final exam. If you score below 80, we're not just gonna leave it at that. We're gonna work and get that score up. Call or message me anytime with details or questions or concerns, phone number, email. Remember that I have this delayed sleep phase thing, which means I sleep like a normal person, only at different times. So I stay up really late and I sleep during the mornings. So if you are worried about messaging me like at 9 p.m. because you're worried it might be too late, don't worry. It's not too late. There's no such thing as too late with me. Conversely, if you message me at 9 o'clock in the morning, you're probably not going to hear back from me for a couple hours. I usually get up at 11. So just keep that in mind. All right? Delayed sleep phase syndrome is what that's called. It's quite an interesting genetic, biological predisposition to when I sleep. My sleep doctor told me that my ancestors used to be the night watchmen, and that when everyone else was asleep in the cave, we were the ones sitting out by the fire guarding you sleepers from saber-toothed tigers, I guess. But anyway, it's kind of a weird, interesting thing about me. All right, lesson 1. Again, this is going to give you 2 days worth of homework. So this is the only lesson you'll need to watch on Monday, and then I'll send you a new one on Wednesday. Okay, the first topic is adding and subtracting fractions. There are 2 topics in this. This is part A. All right, this is something we've been doing for quite a while, and you're really good at it, but we want to review it because we want to start you off this year, John and I do, on very solid ground. We want you to feel like, yes, I get this 100%. This isn't wiggly or weird. It is a very comfortable kind of math for me. So, ready? Now's the part where you start taking notes. Remember, your job is to write down everything that I write down. And just to be weird, John starts out by using letters for the examples. 1/3 plus 2/5. That's what we're supposed to add. We immediately remember, the thing with adding and subtracting is you have to have matching denominators. These do not match, so we have to adjust. I used to use a much more laborious thing where I would write the fractions over each other and then we would adjust going this way. But now that we're older and wiser, we can use a faster methodology for that. We look at the 2 denominators and we go, okay, what's a number that both of these guys go into? Well, and we call that number the least common multiple, right? Or least common denominator. This I know because these are both prime numbers. They're not going to go into each other. We just multiply them together. Least common multiplier is 15. Now I'm just going to make a little note here. This side I want to multiply by 5/5, right? Because that'll get me the 15. This side I want to multiply by 3/3. Notice that I gave myself plenty of room to work here because I knew I would be making little scribbly notes. So copy that in your homework. All right, now we multiply through these adjusting fractions, right? This becomes 5/15, and look what I do. I cross that out with a simple line just so I don't get confused. This is what I want to pay attention to now. Over here, I get 2 times 3 is 6/15, and again, I just line through that. It's the same work that I used to do last year in a different format. This is just a faster way to do it. Now I go back and check to make sure, am I adding or subtracting? I'm adding. And so remember that when we add fractions, we add the numerators and the denominator stays the same. There's our final answer. And I got the first problem of the year right. Oh, I feel good about that. Let's do another one. 2/3 minus 1/8. Okay, again, I'm exaggerating this so I have plenty of room to adjust. All right, again, matching denominators is key. We need a least common multiple. This could break down into 2 times 2 times 2, right? But it's still not gonna have, like, sometimes that helps us. Doing quick prime factors of our denominators is a really helpful way to get the lowest common denominator, but it's not gonna help us in this case because this is a 3, and 3 and 8 don't have anything in common. So we know that multiplying them is gonna be the best answer for our LCM. And now I'm gonna cross that out because I don't need that. Now we're gonna multiply this one by 8/8. Remember, whatever we multiply by, it has to be equal to 1. Top and bottom have to be the same to keep the equation in balance. And over here, we're gonna multiply by 3/3. Okay, this gives me 16/24. And this gives me 3/24. I could put a little equal sign there if I wanted. It just feels cluttery to me. But if that helps you, by all means, write that equal sign in. All right, now we have 16/24 minus 3/24. Denominators match. 13/24, and that can't be reduced. We know this one can't be reduced either because the way we know that for sure is this is a prime number, so I can't break it down at all. So unless the bottom has a 13 as a factor, like if this was 26, 2 times 13, that would be different. But there's no 13 in 24, so we know right away it's not gonna work. Same for 11. 11 is prime. 11 is not gonna go into 15. There's no way. Okay, but that's another step in this process is reducing the answer if possible. All right. This one, this style of problem, I am gonna write in the old way. Addition. 13 3/5 plus 2 1/8. Now, the reason I'm doing this is because we have a mixed number. And that makes things a little bit more complicated, and I want to make sure we sort this out properly before I start using a shorthand approach. What we're gonna do here is we're gonna divide the whole number from the fraction. Now, I know a lot of times I say, just don't even write the mixed number. Go ahead and put it as an improper fraction right away. I know I say that, and I do agree with that, and it would work here just fine. But I'm gonna go ahead and show you how to do this while preserving the mixed number presentation, because this is pretty easy and straightforward too. So what we're gonna do is we're going to ignore these guys and we're just gonna pay attention to this. 5 and 8, we're looking for an LCM, and I remember my rule. If one is prime, then look to see if it's a factor in this one. If not, you know you just have to multiply them together. 5 does not go into 8. 8, once again, we can make this little note if we want. 8 is 2 times 2 times 2. There's no 5s in that, so that's no help to us. And we know that our least common multiple is just gonna be 40. 5 times 8. All right? So now we're gonna adjust both fractions. So this one we're gonna need to multiply by 8 to get the 40 on the bottom, same on the top. And then this one becomes the 5/5. We multiply through, and again, we're multiplying just the fractions. We're ignoring that completely. 24/40 and 5/40. Extend my line out. We're adding in this problem, so this becomes 29/40. And now we can just add the whole numbers, and it becomes 15 and 29/40. It's really a disgusting number, but that's correct. Okay? In this one we added. In the next example, we're going to take those exact same mixed numbers, and we're going to subtract. So this time we have 13 3/5 minus 2 1/8. And I'll tell you the very same thing. We could turn these both into improper fractions and do the subtraction from there. That would be fine, but in this case, it does kind of, sometimes it makes sense to leave the mixed number format here. So we're gonna do that just like we did the last one. We're gonna draw a line to divide, to separate, not to divide. We're gonna ignore the whole numbers for now and just deal with these guys. We already know the LCM's 40, right? So we'll do 8 over 8, 5 over 5, multiply through. I'll slow down after this and give you a chance to catch up. Okay, so there are our fractions, adjusted exactly like last time. I'm getting crazy deja vu, and it's only the 4th problem of the year. But what's different in this one is that we are subtracting. We're subtracting. So 24 minus 5 is 19. Denominator stays the same. And then we subtract here and get 11. So 11 and 19 40ths. Again, this is prime, so we know there's no way it's going to fit into 40. This is done. Okay? So subtracting works exactly the same until you get to the very end, and then you just subtract. This one, E, which is our last, yes, it's our last problem in this section. This one is just a weensy bit kookier. Our same 3 3/5, but this time we're going to subtract 2 7/8. Again, I'm going to use this presentation because I have the mixed numbers. I could change them into impropers, but I'm just going to go ahead and do it John's way. All right, we have the same scenario here. We have the same denominators. We know our LCM is going to be 40. Do you feel like we're in Groundhog's Day? We just keep doing this problem over and over. 8 over 8, 5 over 5, multiply through. 3 times 8 is 24 over 40. Notice that's the same as we've done before, but this one's slightly different. Instead of 1/8, it's 7/8. So when we multiply, we get a bigger numerator. Okay? Now that's not necessarily the end of the world. The problem is that we're subtracting. So 24 minus 35, I mean, we could have a negative number, but we're not going to do that. That's not how this is going to work. And I could explain why, but that's just confusing. So just trust me, we don't want to let that become a negative number. So what we're going to have to do is borrow, just like we do in subtraction sometimes, right? When the top number is bigger, smaller than the bottom number, we have to go over here and borrow. That's what we're going to do. What we're going to do is take this 13 and say, I used to teach my daughters about this with Girl Scout cookies. We're going to go get another box of cookies, is the way I would say it. This becomes a 12. Now we bring this box into the house and open it. And inside is one full box of cookies. Let's say there are always 40 cookies in a box. So now, once we bring in one more box and open it, we've got 40 more cookies over here. So there were 40 cookies in this box, but here we were counting boxes and here we're counting cookies. So that's why we change gears like this. And we change this one into 40 over 40. Now we have way more cookies on the plate, and now we can take 35 away because we have 64 cookies on the plate before we only had 24. I hope that makes sense and I didn't just confuse you further. 64 minus 35 is a mental math problem that I know we can solve. If it was 65, excuse me, I'm yawning. If it was 65 minus 35, that would be easy. That would be 30, right? But this is only 64, so it's one less than 30. It's 29 over 40. Once again, John gives us a prime number. 29 does not go evenly into 40, so that's done. And here we subtract 12 minus 2 is 10. So our final answer is 10 and 29/40. Yay! That's our review of adding and subtracting fractions. If you prefer to change these into mixed numbers, no, improper fractions. Like I said, that isn't wrong, but for this lesson, just go ahead and let's try it in this format to see if it feels familiar. Okay, part B. We're going to switch into a little geometry review. The way John teaches geometry is to mix it in with all the algebra. He does not have a separate algebra class and a separate geometry class. I like that. I think that's fun because it gives us more variety in our lessons, but I want to make sure you know you're getting plenty of geometry in this class. Even though it's called Algebra 1, it also has geometry in it, and that's why it can be used for a geometry credit because it's already in there. All right. We know that there are lines. When we draw a line, we're actually drawing a series of tiny points that are all connected perfectly together. They aren't always a straight line. This one looks like a straight line, but they can go at angles, right? We know that. And it goes to infinity. It goes off my table and across my backyard and over the fence and through the neighbor's yard and off the dimensions of our Earth and out into space beyond our solar system and to infinity. This other arrow goes the other way, across the table, out of my house, across the street, through the woods, off the Earth, out into the solar system and beyond. That's what these arrowheads represent. That's a pretty weighty job for these arrowheads, isn't it, to symbolize infinity. When we want to talk about just part of a line, we can put points on it, and we use letters to name those points. Now we can talk about segments of a line. So if we want to talk about this section right here, we could call it segment AX. And the way that we typically indicate that is like this. I'm just glancing to see. We could also designate the whole line as line AX, and then we would put little arrowheads up here. Okay? We could also talk about this segment. From there to there, we could call that segment AC, or if we wanted, we could call it AXC. We could also call the whole line AXC. So when we're naming lines and segments like this, we have a lot of options, and so don't worry about that. This idea of segments, they can also be called line segments because that's what they are, right? They're segments of a line. I don't hear people use the expression line segments. People usually just say segments. Okay. So we're going to do a problem involving line segments, but first John wants to just give us a little bit of practice in doing a 3-part fraction addition and subtraction. I'll show you what I mean. 10 over 11 minus 5 over 6 plus 1 over 3. So now we need to find the least common multiple of these 3 numbers, all right? So the way I'm gonna do that is I'm going to list the factors of each of these numbers down here. Okay, 6 I can break down into 2 times 3. 11 is prime, 3 is prime. So now what I'm gonna do is make a list and make sure that each of these numbers has their factors in the list. So the first number, I'm gonna need an 11. The second number, I'm gonna need times 2 times 3. Now this 3 is already represented, isn't it? So I don't need to add another 3 because these 2 numbers have a factor in common. I don't need to list a second 3 because that 3 can find himself right there. I'm crossing this off so it doesn't confuse me, and I'm multiplying this through. This becomes 66. That means I need to multiply every number here times whatever they need to get them to 66. I'm a little cramped for space. I wish I'd given myself more space, but I'm gonna make it work. So to go over here, what do I need to multiply to get this 11 to become a 66? 6 over 6. Oh, and that makes it easier for me to do this. 11 over 11. And then this one is kind of tricky, but it's 22, isn't it? And again, the test is I need to make sure I'm getting 66 on my denominator. So I can check and go, oh yeah, that works. 3 times 22 is 66, so that's the right number. Tops and bottoms are all the same, yahoo. Now what I'm gonna do is I'm gonna multiply these 3 pairs of factors, and I'm gonna rewrite it down here since I didn't give myself enough room. So this becomes 60 over 66 minus 55, 5 times 11, over 66, plus 22 over 66. Part of my brain wants to reduce these because I'm so used to thinking about reducing fractions rather than making them bigger. But that's what we need to do in order to add or subtract. Now, calling up your order of operations memory, we're not going to get too into that, but we know that because we're adding and subtracting, we'll just start on the left and work across to the right. So I can ignore the denominators for now and just look at the numerators. 60 minus 55 is 5. I'm going to make a little note to myself. 5 plus 22 equals 27 over 66. Okay, that feels pretty good. But I know that I can reduce this because this is not a prime number. 27, I'm just gonna jot this down. It's 3 times 3 times 3, isn't it? 9 times 3, we break the 9 down into a 3. 66, we already know how to break that one down. That's 11 times 2 times 3. Do you see how I'm just making little prime factor lists of each of these numbers? And now I can see, oh look, they have a 3 in common. So if I mentally divide 27 by 3 and 66 by 3, that's the same as saying, let's just eliminate these common factors. And our answer, our final answer will be 9, 3 times 3, over 22. That's the same, it's a different mental process, but it's the same mathematical process of saying, let's divide by 3 over 3. 27 divided by 3 is 9, 66 divided by 3 is 22. So I'm showing you 2 ways to think about doing the same thing. Okay, there's our answer. And we're now ready to take this work and apply it to the line segments. I don't know why John put, this problem seems like it should have been in the other section, but that's all right. We can be flexible, right? Now we're getting to the part about the lines and segments, 1.2, and then there's a picture. Good, I like to draw a picture. It's a line segment. It has dots on the end, not arrowheads. It has another dot somewhere in the middle. And these are named A, B, and C. All right, so far so good, right? Segment AC measures 10 1/4 units. So that's my symbol. It says segment AC equals 10 1/4 units. Segment AB, and we'll look at the picture in just a minute and make sense of this, measures 4 3/7. Find BC. Okay, let's look at this and get our bearings. AC, that's the whole big long thing. That's 10 1/4. AB is this clump. I'll draw a little arrow. That's 4 3/7. We're supposed to find, we're supposed to find BC, which I'll make wiggly. since it's the mystery, we're supposed to find this much. So we can see, okay, how can we find that? Well, we can take the total length of the segment and subtract out this part of it, and that will leave us with that part of it. Does that make sense? If it was just, let's just pretend this was 10 and this was 4, then we would know this would be 6, right? Because 10 minus 4 is 6. However, John has given us drama because he's given us fractions with unmatching denominators, because that's just the way he rolls. So we're going to do subtraction, and I'm going to leave this in mixed number format just to show John that I can play the game his way if he wants. Least common multiplier, okay, again, we ignore this least common multiple. 4 and 7. We know that 4 breaks down into 2 times 2, but that doesn't do us any good. There are no 7s in 4. There are no 4s in a 7. So we multiply them together to get a least common multiple of 28. I'm going to just erase that so I don't have to look at it. Notice that when I say erase, I really mean squiggle out. Please don't erase. Please don't erase. We'll talk more about it. Erasing is just a source of frustration. Okay, so we want our denominators to be 28. This one I'm going to have to multiply by 7 over 7, and this one by 4 over 4. Cool. So this becomes 7 over 28, and this becomes 12 over 28. Now, if we're adding, it's fine. If we're subtracting, we have drama. And we're subtracting. All right, fine. So we have to do what we practiced just a minute ago. The cookies come in packages of 28. There are 7 on the plate, and you've been told that you get to eat 12 of them. Well, there aren't enough there, so we have to go to the cupboard. There's 10 boxes of cookies in the cupboard. Hallelujah. We cross them out. Now there are only 9 because we're taking one. We're opening it up, and we're taking the 28 cookies inside, and we're adding them to the plate. We subtracted one and we added one, so our number is still in balance. This now becomes 35 over 28. We have more than one box of cookies on the plate. Now we've got more than enough so that we can eat 12, and that leaves us with what? 23 cookies on the plate. They come in boxes of 28. All right, that all worked out just fine. 9 minus 4 is 5. There's our final answer. So this number is the length of AC. So if we, or BC rather, sorry, we can say segment BC equals. If we wanted, we could make our answer extra cool by adding that. And I know you want your answers to be as cool as possible, right? Okay, so that's how we can find out this segment. There are a ton of fraction problems in this homework. Let me just show you. Adding and subtracting fractions. Here they are, just fractions. Now we start with the mixed numbers. Adding with mixed numbers, subtracting that it requires borrowing. All right? Whew. And then here are 3 segment problems. That's a lot of problems, but again, we're going to do all 30 problems over 2 days of homework. So you can decide. You can go do all the evens and then do all the odds. You can do odds and then the evens, or you can do 1 through 15 and then 16 through 30. I suppose you could do 16 through 30 first if you preferred, and then the 1 through 15. The 1 through 15 are definitely easier than the 16 through 30. So keep that in mind if you want to do the hard ones first. But 2 days of homework out of this set of problems, and then I will meet with you again on Wednesday, and we'll cover lesson 2. I hope that makes sense to you. I hope you are excited to get going on this year's homework. I also want you to think about when you want to video chat with me. I'll reach out to you later in the week and ask you to tell me a time and a day that you would prefer. The options are Thursday and Friday, anytime between noon and 3 p.m. Remember, these usually, the chats take 15 minutes at the most, right? We look at your parent signature, we chat, and we do a quick review problem from one of the earlier lessons. So it's not a really long thing, but I want to have a defined time. Okay, I'm done talking. Thank you. Goodbye.